W Physics. I'm Mr. McConley, and we're going to go over an example of Fnet problem today. And if you recall from a previous video, we figured out an Fnet problem where we were looking for the coefficient of friction. And in that scenario, we had to pull the box of bricks at a constant speed. But in the scenario today, it's a different setup where you're actually going to be accelerating the object. So Cheyenne's going to read me a problem, and I'm going to start jotting down some givens. Go ahead.
A 225 kilogram crate is pushed horizontally with a force of 710 newtons. If the coefficient of friction is 0.20, calculate the acceleration of the crate.
You said the coefficient was 0.20. Did I get all my givens? And calculate the acceleration. That's the last thing you said. So from what you read me, that's what I wrote down. Step one, I have to get a picture that makes sense. So I'm going to draw something that looks like a crate to me. There's a crate. For some reason, in my mind, when I draw these pictures, I always am pulling the thing to the right. I don't know why it doesn't have to be like that, but since I'm pulling it to the right, my applied force, which was claimed to be 710, is going to pull to the right. But when you're pulling something, of course, we have the thing that always opposes you, which is friction, bench. We always have gravity relentlessly pulling down on us, and then we have the normal force, which is that force that's kind of holding that crate up. So now I got a good picture. Next step, where do I go with this? I make an Fnet equation. So the net force is equal to all the forces in that diagram added up. So we got a frictional one, and we got an applied one, and we got a gravity, we got a normal force. And at this point, most of you have learned that if the object's sitting on the ground like this, we can immediately cross out those two. That's great, because it simplifies things a little bit. And now we got to start thinking, well, what is Fnet the same as? And Fnet's the same as? Very good. A lot of answers from the crowd. Frictional force. What's that the same as? That's mu times Fn. Says Fn. But she also took it a step further and said it's mu and Fn's the same as Fg, and Fg is the same as m times g. And Chase's mind is just blown. Well, he'll recover. And then over here on the applied side, we know that this is just going to be a 710. I'm just going to carry that on now. So what I'm trying to do, and what I typically try to do when I do these problems, is I show the arrows to show you what my thought process is. Now some of you can do some of these intermediate steps in your head. That's okay. But I'm showing you that I'm thinking about this, which I know is the same as this, and I know it's eventually the same as this. So I'm showing you the way my brain's stepping from one step to the next. Now I'm at a good spot, because I can see acceleration, and I know the mass, I know the mu value, I know the mass, I know gravity, I know everything else in the problem. So let's just finish it off. Let's plug it in. We got 225 kilograms, as stated in the givens. We got acceleration, which I'll still just leave as an A for now. We got the mu value, 0.2. We got the mass again, 225 kilograms. Notice I'm being very particular to plug in my units every time I write a number, because that's the way the Regents wants you to do it. Every time you write down a number, you need to have the units attached to it. Gravity is negative 9.81 meters per second squared, and tacked on the end is that applied force of 710. Now through the magic of a calculator, we solve, and the acceleration comes out to be 1.2 meters per second squared. So what that says is if you had a crate that was 225 kilograms, and if you applied that force to it, and if there were that much friction, then this crate would start speeding up at an acceleration of 1.2 meters per second squared. How does that compare to gravity? Compare that just roughly to gravity. Gravity stays a 10. What's this in comparison? What? Yeah, it's slightly less than a 10. So it's not a very big acceleration. So that's it for today with another Fnet problem, physics.